Thank you for joining us today for the final webinar in a series that showcases the new modules of the Carlson 2014 Takeoff Suite. My name is David Sandford, and I am the Director of Sales for Carlson Software in the South Central region of the United States. In today's webinar, I will be demonstrating Carlson GeoTech. Carlson GeoTech is not just for geotechnical engineers, as the name might imply. It's also for civil engineers and contractors. One of the really neat features of this new module is its ability to quantify rock cut on land development projects. And this is significant because identifying these zones of rock cut on a project can have a tremendous impact on your project's budget, making sure that it's accurate. Like the other modules of the Takeoff Suite that were highlighted in the preceding week's webinars, Carlson GeoTech can be purchased individually and perhaps added to your existing software, like if you have the Civil Suite, or it can be purchased bundled as the Takeoff Suite. The Takeoff Suite, as you can see, contains Carlson Construction, Trench, CADNet, and GeoTech. There are 4 main menus to Carlson GeoTech. Those are drill holes, Strata Calc, grids, and map. And like our other programs, it's very intuitive, very easy to learn and use, basically working from left to right and top to bottom. Under the drill hole menus is where you go to define, place, and edit drill holes. There's routines for creating drill hole reports, also routines for labeling your drill holes. The Strata Calc menu includes the same triangulate and contour powerful routine that's inside Carlson Survey and Carlson Civil that builds tin surfaces. This is also where you would go to create your isopack maps, fence diagrams, geologic column profiles. Here's where we're going to go to do our strata cut depth color maps. That's one of the end products of today's results. The grid menu, under the grids menu, it's similar to the triangulate and contour features, but it works with grid surfaces. So we've got a grid inspector. It's a very handy tool for inspecting multiple surfaces at any given time, where you can see the top steps of certain strata, and you can also come in here to get your volume calculations. And then the last menu is the map menu, and this contains many powerful tools for producing great looking maps. It includes annotation routines for angled distances, labeling points, either coordinates, northings and eastings, or lat longs or spot elevations. It allows you to build a title block. Say if you're making a boring location map, you can insert a title block, bar scale, north arrow, and finally, one of the very neat features of this menu is its ability to place a Google Earth image into your drawing. Very cool. If you have any questions today during the webinar, please type them in. I'm going to do my best to try to answer them during the webinar. If I can't get to them, Karen is standing by keeping a log of the questions as they come in. And again, I'll try to answer them as they come up when it's appropriate. If I can't get to them all, we'll answer them via email. Let's go ahead and dive into the software. Many of you are probably familiar with this site. We've used it for several different webinars before. But this is a hotel site. And I'm going to go ahead and start by placing boreholes throughout the site here. And it's very simple. What I have already done here previously is inside Carlson Civil, specifically in SiteNet, I have come in and created existing ground surfaces and then my finished ground surfaces, including subgrade for the buildings and the parking lots here. So I click on the pickaxe looking icon here to launch into Carlson GeoTech. And here you can see the menu structure here across the top. I'm going to start in Strata Calc, and like I said before, I've already created my existing and design surfaces. Start at the top here and set my boundary polyline. I'm going to pick this white polyline right here, select it, and then I'm going to go back in and set my existing ground surface and select my original ground tin. Click open, and that's done. And I'll go back into Strata Calc and set my design surface now, and that's going to be my FN tin. Again, these were created previously using Carlson Civil SiteNet. And now, under the drill hole menu, we'll start right here at the top to find drill hole. And I'm going to clear these out of here first, and we'll just populate this screen here. So when you first launch into drill hole, this is what you're looking at. You select your symbol for your drill hole. I'm going to stick with the SPT12 symbol, and I'm just going to add my strata here. So I click on the Add button. Then I'm going to go ahead and give it a strata name. I'm going to call it topsoil. And I'm going to design by strata method by depth. The different methods are listed here down below for creating your strata. More information on that is contained if you click on the Help menu. Describes in detail the different modeling methods here for creating your strata. So I'm going to input my my boreholes by depth. So I'm going to click OK, and that adds topsoil. And I'm going to add a couple more in here. I'm going to go ahead and add. And I'm going to make a clay layer in there. Again, I'm going to define that by depth. Say OK. And then finally, I'm going to add in one more. We'll call it rock. Again, we'll choose by depth. And say OK. So I've got that populated. And these are, when I am prompted to insert the drill holes, it's going to prompt me either by depth or thickness. If I choose the depth, for placing my drill holes, it's cumulative. So if I've got a ½ foot of topsoil and 3 feet of clay, I'd have to put in 3½ feet for my clay layer. So I find it's easier, primarily the GeoTech reports I've seen in the business, they'll show a thickness of the layer. So I'm going to go ahead and choose thickness and say OK. And then I'll go ahead and place my drill holes. So back to the drill hole menu, I'm ready to place drill holes. And I picked locations throughout my plan here. I'm going to start right here. And it's prompting me, you can see at the bottom there, to place my topsoil thickness. And I'm going to say I've got a ½ foot of topsoil there, 3 foot clay layer, and my rock thickness, I'm just going to put it down to 20. And then I get a verifies for me my surface elevation there that it pulled off of my existing tin model, and I give it a drill hole name at this point. I'll call it B1 and save. And I'll just continue this process and place 6 or 8 different drill holes in here. So I'm still in the command. It's prompting me now for another drill hole location. I'll put one here at the corner of the building, and this time I'll use I don't know, maybe 4 inches of topsoil, 2½ feet of clay, and again 20 foot of rock. And we'll call that one B2. Now I'll just continue placing boreholes throughout the site here. I'll put another one inside the building here. We'll go back to a ½ foot and 2 foot. And again, we'll stick with 20 on the rock. Call this one B3. So very, very simple as far as coming in here and placing the boreholes. Let's put another one maybe in this pad here. We'll go back to ½ foot, 2 foot on the clay, 20 foot on the rock. I think we're up to what, B4 now. Save. 1, 2, 3, 4. We'll place a couple more in here. I'll place one here. 0.33, 2½, let's say, and 20. and then we'll call that B5. We'll do one more over in this corner of the site here, and back to a 1/2 foot, 2.5 for the clay, 20 for the rock. Call this one B6. And save, and we're done now. So now I've got my boreholes placed in my drawing. I can edit individual boreholes now by picking them on the screen. And it displays for me here my depth of topsoil. So it's more of a spreadsheet type editor where I can come in and edit either the depth, bottom elevation, thickness, any one of those values. Also tells me again where my boring hole is located, so I can add a description. I'm just going to save out of here and exit the command. Let's go in and label our drill holes now. So under the drill hole menu, I'll go drop down to label drill holes. We've got standard drill hole text or drill hole text formatter. I'll go with the standard drill hole. And what I'm going to use for labeling my drill holes, I would label the drill hole name. I'm going to go ahead and put the surface elevation on there, strata name. I can have it label the strata top, bottom, or none. I can label the thickness, which strata to include. I can select those or select all. Text alignment, I'm going to go ahead and put that on the right, and let's just say OK here. And like many of our annotating routines and labeling routines, sometimes it's an iterative process to get the labeling in the format that you want. Once you go through and get those labels situated and created the way you want them, you can save those out and then throw them up on the server for other individuals at the office to use so that you're consistent with your labeling. Because that's key in offices, to be consistent with your labeling. So I'll say OK. And I can go ahead and window all of the boreholes now. And it's prompting me. I selected to select. I wanted to select which strata layer, so I can select any one of these layers or all of them. I just want to select the top surface of my rock here. I'm going to say OK. And if we come in and look at this now, you can see the surface elevations labeled and the top of the rocks labeled along with the borehole itself. So that's the label borehole routine. Next thing I want to do under my strata, under my drill hole is define my strata. You can see I've populated this dialog box. It's let me clear this out. What you do when you first come into this routine, after you've placed your drill holes, you can have it read your drill holes. And I can come out here, zoom out, and have it process that for me. So after you've placed your drill holes, go ahead and select Read Drill Holes, and it reads the ones from your drawing. And I can come in and edit these individually. So for the top soil layer here, I'll click on it, edit it, put a color of green on there, say OK. Under the clay, I'm going to edit that color. And different values you can edit within here, the different hatch patterns. This is going to be useful when I do my drill hole reports and my fence diagrams. So I'm going to put a different color in there for clay. We'll just put that at yellow. Say OK. OK again. And then finally my rock surface here, I want to edit it, and we'll select the red color for it. Say OK. So I've saved that. Let's save that out now and exit out of there. Okay, now I can show you how those colors are worked. First off, with the drill hole graphic drill hole reports. Select it. Prompts me to select the drill holes. Again, I can window all of the drill holes. And it's going to create a graphic report for me showing the log, description, depth, thickness, etc. It's going to have be an 8.5 by 11. I'll do this in model space. I'll say OK. Pick a point to insert my log. I'm going to go ahead and put it right there. And you can see here is a graphic report of the different boreholes, B1 through B6, and showing the different color variations for the different strata within my model here. So I've got the drill hole reports done. Back into drill holes. Let's go over to Strata Calc now. And let's hang on here a second. Let's go back here, and I want to make my strata surfaces within here. That's going to be under strata, make strata surfaces. So it's going to create different surfaces for all of these different strata I've just created using these boreholes. So I'll go ahead and make my strata surfaces. It's doing that right now. Again, it's making 3 different surfaces for the topsoil, clay, and rock layers I have as defined by my boreholes here. And I can make a specific grid file. What I want to do is ultimately I want to compute my rock quantities on this job. So I'm going to make a strata grid file using a file that I've created earlier for the final ground. I'm going to go ahead and create a grid file of the top of rock here. I say OK. I'm going to window select all of my drill holes, select OK, and the strata I want to process here is my rock. I'm going to say OK, and then what I want to create is a surface of the top elevation of that rock, and then I'm going to compare it to my final grade DTM. I'll say OK, and I'm going to go ahead and call this top of rock. And this will create a Carlson grid file. And I'm done, so I'm going to exit out of here and click exit again. Let me show you next the fence routines that we have for fencing. Fence diagrams are basically a profile of your surface. So I'm going to strike a polyline through the site, beginning here, coming back to here, and use that as my fence line. So I'll go up to Strata Calc, and we've got either quick fence or fence diagram. So I'm going to select fence diagram. And similar to our profile and Carlson Civil, Carlson Survey, you set your horizontal and vertical scales here. I'm going to go ahead and have it hatch my fence and say OK. And it's prompted me to select that polyline. So I'm going to select that polyline I just drew. And down at the bottom, it's specifying the grid elevation, starting grid elevation of 815. I'll accept it. I'll accept the 825 top of grid. And then it's prompting me for a location to draw the fence diagram. And you can see, going from the low side of the site to the high side of the site, I didn't have any bore holes down here, so the modeling method, once it picked up those different bore holes in there where it started to find the rock quantity, as you can see in red, you can see the various layers throughout the site here. So that's the fence diagram. Next thing I want to show is I've already got a finished ground tin inside here. I want to compare that to my rock layer and create a cut color map. Before we get there, Karen, are there any questions yet that have come up that I might need to answer?
Not at this time, Dave. No questions have come in yet.
All right, that means I've either put them to sleep or Or I'm doing a good job, huh?
I think you're doing a good job.
Thanks, Karen. So I'm going to keep moving. Next thing on the list here, we've done the fence diagram. Let's go ahead and do the cut color maps here. So under Strata Calc, I want to go ahead and draw my Strata cut color maps. And the Strata I'm going to process, and you can see it's populated the list here. I select either topsoil, clay, or rock. I'm going to go ahead and use the rock surface. Say OK. And there it has produced the rock cut. And it's comparing that. Remember, I set that finished grade surface earlier when I first started here. Now it's prompting me for a legend to place and a size for my legend. I'll print the summary here. So it shows me my cut depth. And I've got a 5 or 6 foot select fill requirement underneath the building pad here. So you can see the cut depth. It's comparing that depth of rock cut on the job here. Let's dive into the grids menu now. And under the grids menu, we've got the grid inspector. And the grid inspector works with either grid files or tin files. And you can populate those from the list. Setting them here, I'm going to go ahead and set my top of rock in here as well. Say OK. And what this does is this allows me to place a spot elevation basically throughout here. You'll see as I hit OK. And when I hover through my data, it's showing me original ground surface, finished ground surface, and top of rock surface. And if I want to place, like down here where I've got the deep cut, I want to place a label there, it'll go ahead and label that for me as well, just by picking it on the screen. So I can pick a couple of locations on there, and that shows me where those potential problem areas are. It's going to drive the cost of my site up, because I've got some pretty deep rock cuts there. Top of rock at 816, and my finished ground, which is, again, my surface minus my subgrade, is at 813.7. So about 4 feet of rock cut in that area right there. 3 feet, excuse me. So that's a grid inspector and placing the labels. Let's go ahead and get a report now, a volume report of this rock cut. That'll help us determine whether or not we want to raise or lower the site, or raise the site. Probably don't need to lower it because we've already producing 3 feet of rock cut in some areas. So let's go back into Strata Calc, and I'm sorry, back into grids, and we want to do a 2 grid surface volume calculation here. And I can use inclusion-exclusion perimeters. So I'm going to go ahead and select this outer boundary as my inclusion perimeter. Not use any exclusions. And what I want to compare is my base rock elevation. So I select it as my base file. I want to compare that to my finished ground grid file. Click Open, and I can report in tons if I know the density of my material. I'm just going to go ahead and report this out at 1:1 and say OK, and it quantifies for me the depth of rock cut I have on the job. Shows me my average cut depth, a little over 1 foot. Shows my maximum cut depth is about 3 foot in those deep red zones right in here that we looked at earlier and labeled up, 3.19. We've got a total rock cut volume then of 1,600 cubic yards on this job here. The fill is showing here is showing the fill above the rock surface there. So that's not my total fill on the job. That's just the fill comparing these 2 surface files here. So that's very valuable information. I can save that out as a text file, send it to the printer, print it to the screen. I'm going to go ahead and exit out of there. And finally, we'll go into the Maps menu and show you some of the features inside the Map menu here. So under Map, we've got different labeling routines for angle distance, distance with leader, labeling coordinates, lat longs, spot elevations, as you can see. So The angle distance is very similar to our annotation routines that we have inside of Carlson Survey and Carlson Civil. And you can see as I click on it, it labels the bearing and the distance for me on whatever line I select here, whatever polyline I select. So that's handy for labeling up boundaries, etc. Maybe I need to put a couple of spot elevations or lat longs on this job, so I can use the, let's look at both of these, label coordinates. Under the label coordinates, similar to placing the drill holes, it's going to prompt me for a symbol, so I can select my symbol. I can put a box around the coordinate labels if I want to. Specify northing, easting, and elevation, or northing and easting only. We'll go ahead and do just the northing and eastings without any elevations. So you can see that grays out the elevation prefix now, and set your number of decimal places here for your coordinates. I'll go ahead and say OK. And I'm going to go ahead and pick a point out here just inside my data set. And you can see it places the coordinate value for me there, northings and eastings. And you can place those wherever you want. It's still in the command, so I can place another one down here in that vicinity. So that's how that works. The label lat long is very similar to that. If I needed to have a lat long on there, I'd enter that command. Draw with leader, perhaps. We'll go ahead and label a lat long on here just to show you how that works. See, I get real-time feedback right away up here in my upper left-hand corner. Maybe I want to put one right at the end of that polyline right there. We'll draw it off to the side. Labels the lat long for me. Should mention, I guess, prior to going into this, I did go into my drawing setup and set this up for state plane coordinates, the California Zone 6. So if we're producing a, let's say we're producing a boring location map of this site here. I might want to put a north arrow and a title block on this. So let's look at that. Title block, select my paper size here. I already know that 100 scale should work pretty well for me here. I'm going to go ahead and select it, say OK. You get a preview of it there as far as the size. You place it as you need to. And then it prompts you for things such as title, so we can call this, Hotel Site 1 or whatever we want to call it. Hotel Site, project name is, I don't know, California Hotel, whatever it's called. Drawn by, you might want to put your initials in there, the date, put today's date in there. Scale is 1 inch equals 100 feet, and we'll just call it figure 1. Actually, let's change that to boring location map. Might be more appropriate here. Boring map for the California Hotel. We'll say OK. It's populated that for me down here in the order file. So the next thing I'll want to do here is probably put a north arrow on there. And we've got several different north arrows to choose from. Choose the north arrow you prefer, or if you have your own north arrow you'd like, you can actually use it as well. So we'll select this one, go ahead and pick a location for it, and it places the north arrow in the drawing. Next thing I want to do is I'll go ahead and put a bar scale in there. And I'm going to set this at 100 scale and say OK, and then pick a location down here towards the bottom to place my bar scale. So my boring location map is pretty well done. I can freeze and thaw layers as I need to, depending on what I want to show on here. Last thing I want to show inside the map dialog box, we've got a really neat feature. Only other program within Carlson that has this feature is Carlson GIS, and this is to place a Google Earth image. So I've already showed you earlier that we've got the project site. This particular project is located in the California 6 zone with a projection of State Plane 83. So you got to set that first, and then under the map, you go right into Place Google Earth Image, and this will launch Google Earth as long as you have Google Earth loaded on your computer, and then you can specify the size of the image you want to place in your drawing here. So right now you can see it's launching Google Earth, and I can select either monochrome or color. I'm going to select from my drawing the size of the image I want to place, and I'll just go ahead and window an area about like that. It's going to place it on a layer called Image. I'll say OK. And now it says from Google Earth, run File, Save Image. So let's go over to Google Earth. There's the site. So I go to File, Save Image. And I'm going to put it in my GeoTech subdirectory here and call it Hotel. And it's going to create a JPEG image for me here. So click Save. And then we'll go back into Carlson, click OK, and then we need to select that particular file, click Open, and there it is. There's our image in the background. I can crop this by using some of our features here under the View menu to crop the view of the image. It's on a layer called Image, so I can freeze or thaw that layer as I need to. But that's what I planned on showing today. Again, this is Carlson GeoTech. It's part of the Takeoff Suite, so it can be purchased individually for $15.95, or as the Takeoff Suite, it sells for $7,500. Here is my information. If you have any questions, again, please type them in. Karen, have we got any questions?
You did not have any questions from anyone.
Okay, so it's my lucky day.
I was actually able to follow.
Great. Do you have any questions, Karen?
No, not yet. I was able to see what you were doing, so
great.
Seeing as I don't work in this stuff, that's good. Oops,
well, that's
here's
great.
a question. You just got a question.
Okay.
How do we get PDH confirmation? Oh, they want to be able to get classes for this. I will look at that and send something to you later.
Sure. Yeah, I can do a PTH certificate for the engineers that want to keep track of that. Absolutely. So if you just let us know by sending a list, either by submitting a question in the question comment like you have, let us know who needs the PDH certificates. Send me an email. I'd be happy to create the certificate and send that to you for attending today's seminar. If you have any more questions, if you think of any, please send them either to me at dsandford@carlsonsw.com. Thanks for attending the webinar today. Have a great afternoon. Thanks.
Okay. Thank you.